Okay, well, my name is Ashwani Yadav, and I'm done mtech in iiest Sipur in the renewable energy department and btech from mechanical engineering. So, well, in first lecture we have learnt about the basic idea of free charge. Okay, हम लोग free charge के बारे में basic introductions we have idea about free charge and what is the real meaning of the free charge and the formula we are going to apply for the free charge and where it can be applied. So we have seen in the previous lecture. Now we are going to start, suppose we have two charge of same nature is same, both are positive, then what is the electrostatic interaction? Then electrostatic interaction is given by coulomb force and this has position vector r related to each other. F is a vector quantity that is equal to product of the charges. This is q1 and this is q2 by 4 pi epsilon naught r square, and this is the magnitude and this is the unit vector, and the directions is line joining the 2 points. This is direction of the force, this is direction of force. Okay, and direction is line joining the 2 point charge. This is the point charge and this is also a point charge. So the expression of the force is only valid for 2 point charge separated by a distance r, and the direction of the force will be the line joining this one. Okay, just join the line and this will be the direction of the force. Okay, this is kept in a space, and I tell you, this is look at the force. Is nothing to understand this because it is experimental. It is given by coulomb. It is given by coulomb. That's why it's called Coulomb's law. Okay, and it is experimental. By doing experiment, this formula has been given. Okay, but important thing you should know that force is related to electrical property of the medium. Okay, you can see this constant. You can also write the force well. This is basic, so everybody know this expression of the force, and just I am trying to emphasize one thing, that force we have 1 by 4 pi epsilon naught q1 and q2 and I square. This has no physical meanings. This is exactly q1 and q2 and r square distance, but this term, this is permittivity of given medium. You can consider here vacuum or air, and this value is nothing but 8.85 into 10 to the power I think minus 12, and this is coulomb square. Take from the dimension of the charge, coulomb square an inverse, a meter inverse. Sorry, it is square, then you can take it minus 2. Okay. So I mean to say, I just want to tell one thing, that force has something to do with electrical property of the medium. Why? How can force is affected by electrical property of the medium? I tell you one thing, that is polarization. We'll see what is polarizations, and this, and you know, everybody know that this will create electric field, and electric field will cause the polarization of this medium. So the polarization of medium is responsible, can affect this force. We will consider all these factors in coming lecture, how these electrical properties can affect this force. But you should know this is epsilon naught. If it is high, then medium is strongly affected by electric field. Okay, so this force is really modified if you change the medium. Okay, suppose this is kept in a vacuum and this is epsilon naught. But what happens when you kept this 2-point charge rather than vacuum? Then we have modified force 1 by 4 pi epsilon naught q1 q2 by r square. This is the same thing, but one factor 1 by relative permittivity. Okay, this is relative permittivity of the medium. Okay, so I mean to say that force will be modified by this much if you kept in the medium, and this is going to be, you know, we are going to study in details in coming lecture how medium is polarized. This will act as a polarization vector. How can it affect the electric field in the medium? So we are going to study in details in coming lecture, but for now time being, just you can say that this is the modified electrostatic force between the two charges if two charges are kept in a medium. But keep in mind, this is applicable for point charges. Keep it simple. Okay. We have one term, that is relative permittivity. ER is nothing but E by epsilon naught. This is for medium, given medium. Okay, and this is, you know, for vacuum. So this is much. Okay. This is permittivity of medium. This will be given, just to multiply this term you will get the your what you want for the medium. Okay, this is permittivity of a medium. This will be given by, it is found by experiment. Okay, so I just to see the forces now. Coulomb's law in vector form. Okay. This is y axis and x axis, and we have charge is q1 and q2, and this force will act one force on charge 1 due to q2 and force on q2 due to 1, and this is action reaction pair. Action reaction pair. Okay, it is just a line join this point, so it is called central force. Central force diminishing by factor 1 by r square. Okay, now its position vector r1 and this one is r2. Okay, and this is r21. Okay, this is central forces and diminishing with this distance like this 1 by r square. When you increase the distance, force will reduce. एक घट जाएगा. This will diminish. Okay. Now, this is the position vector, and r2n is nothing but r2 vector, position vector of r2 minus position vector of r1, and unit vector r21 is equal to vector r2 minus vector r1 by magnitude. You must have this vector. Now it is clear that F21, now I can tell that a direction of F21 and unit vector F21 has same direction. Same direction. You can find, if you unit vector, then you can find the direction of the force. Now the unit vector, now the force F21 is nothing but, as usual, 1 by 4 pi epsilon naught r square unit vector r and q1 and q2. So f q1 q2 by 4 pi epsilon naught r square r2 minus r1 magnitude and vector r2 minus vector r1. Okay, this is expression for Coulomb's law in vector form. You can find the position vector once you know its coordinate in x, y coordinate. So it has x and y coordinate, and it has x2 and y2 coordinate. So how can I write the position vector r1? Nothing but xi plus yj. Similarly, r2 is equal to 1 and 1, r2i and y2j. Okay, and r2 minus vector 1, just to subtract this. Okay, so once this position is specified, then you are able to find this one, and finally this expression. Okay. Well, now it follows superposition principle. Okay, means f vector resultant is f1 plus f2 plus f3 plus f4 and so on. this is your superposition vector. Suppose you have charge q1, discrete charge q2, q3, q4 and so on, and you want the force on this q, then you just simply add the force due to charge q1 on this, then force q2 on this q3 and q4. Just simply add this forces vector form, just vectorally it add. This means this is not affecting each other. This force, this is not affecting each other. So this interaction between two charge, interaction between two charge is unaffected by the remaining charges. This is superposition law. But one thing I like to tell you, that this is simple, everybody know this, but do you know this is only applied in Coulomb's law. Is only applied where superposition is allowed. Superposition is allowed. Okay, what happens? Can you apply Coulomb's law in crystal? Suppose this is crystal. Okay, we have electron and this is iron, so many electron and iron. Then what? Can you apply this Coulomb's law and law of superposition? No, because I am just telling you that you can apply, and here there will be modified electric field called a screening electric field, a screening electrostatic field, or you can say force. Okay, and in atom everybody know shielding force, shielding effect. Okay, presence of the electron affect the forces between nucleus and electron. So just I want to emphasize in one thing where you can apply this law. Okay, this is a very simple one. We are going to study simple cases. We will understand all these things. We will really study all these things in solid state physics, and all these things atoms related in atomic physics. Okay, and a spectroscopy. Suppose we have two large conducting a sphere having charge q1 and q2, broad closure, force q1 and q2 by 4 pi epsilon naught r square, and this is distance. R is distance between two center. Can you write this? Is it true? No, it is not true. It can't be happen like this, because this is not point charge, because it is not point charge. electrostatic force will not be like this. Okay, because this will affect its charge distribution. This will affect the charge distribution. Charge distribution will be affected by the presence of this charge. This is large conducting sphere, and this charge will not be distributed uniformly like that as earlier before coming closer to this sphere. Okay, charge will not be concentrated at the center. Charge will not be concentrated on center. So Coulomb's law can only be applicable to a point charge. Coulomb's law is applicable to point charge. Suppose we have 3-point charge Q, Q and Q of equilateral triangle A. This is equilateral triangle. Okay. Same charge are kept at the vertices of the equilateral triangle. You know the geometry. This is the centroid. This is the centroid, and distance. Suppose O, A, B. See, perhaps I'm not. I'm remembering it. You can derive this, but I think it is A by root 3. You can check it whether I am right or wrong. But I think this is. By geometry, AO is equal to A by root 3. Okay. So this is point of equilibrium. This is point of equilibrium. If you kept any charge here, it will feel net force is 0. Okay, any net electric field is 0 or net force is 0. Similarly, take a square and this where it diagonally meeting Q, Q, Q and Q. This is point of equilibrium. Now we have pentagon. If this side is equal 1, 2, 3, 4, 5, this will point of equilibrium. Circle. This is built with the point of equilibrium. If charge is distributed like this, and this is symmetrical point on this ring, and the force, you put the charge at this point, the force on this charge will be 0. Okay. Now, some easy problems for you. That is, we have A, B, C vertices of an equilateral triangle. This is L, L, and L, and we have charge Q and Q and Q. So net force will act on this line, join this line, okay, and then join this line. This is direction of the forces. This is charge, then it will apply electrostatic force, and this angle is 60 degree. So we have resultant, F resultant, and F electrostatic force, F electrostatic, and this will be your 30 degree and 30 degree. And question is, how can the system of charge be placed in equilibrium? Net force is in this direction. So you must have to keep a point of charge Q. I don't know how much. You have to find Q, but it should be placed at this point, that is centroid of this triangle. And you know this distance is nothing but L by root 3. Okay, in this way I can, but this force negative charge, because you have to have, it have to apply the force in this direction. And we all know that negative, positive and negative charge attract each other, and positive and positive charge repel each other. So we have F resultant is nothing but 2, one component of this force and one component of this force, 2F cos theta. Theta is 30 degree. 2 into Q1 into Q2, Q square by 4 pi epsilon naught L square cos 30 is value is root 3 by 2, and this force, this attraction force, you can say that Q by 4 pi epsilon naught L by root 3 whole square, and this will be equal, otherwise how can you maintain this equilibrium? Q and 4 pi epsilon naught L by root 3 whole square. This is going to be vanish, and this one is Q, and this will be cancelled out. So we have left with Q is equal to this much is going to be root 3. So we have Q by root 3. So this much charge you have to put, and this Q is nothing but Q by root 3. So we have this much charge. You must have to put this charge at this point to maintain the equilibrium of the system. Okay. Now we will continue some good problems on the concept of Coulomb's charge and use the simple expression of this force. Okay. One more illustration. We have two identical, this one and this one has mass m and mass m. This is a sphere and this is also a sphere of mass m and this is your angle theta, and this is length L. Look at this system. This is like this, staying in equilibrium with each other. Just staying in equilibrium. Okay, like this, like this. Okay, so you have to find why it is like this, because tension force is along this direction, theta, this is T cos theta, and here mg, and this is T sin theta. Okay, then why this is not coming in this direction? Because both have same charge q and q. Then find q. What will this charge do? It will apply the force, electrostatic force, in this direction, and here in this direction too, force. So we need to find is how much charge it passes, okay, to balance this force T sin theta. This is your question. Simply balance the force okay, you can do this. Simply balance the force. T sin theta is nothing but F electrostatic force, and T cos theta is equal to mg. So tan theta we have Fe by mg. Now mg tan theta is equal to Fe. So mg tan theta is nothing but q square by 4 pi epsilon naught, and this is the distance between the two charges. This is L, so this is L cos theta, and this will be L sin theta. This much L sin theta, another one L sin theta. So we have R is nothing but 2L sin theta. So this is R square. So we have R square is equal to 4L square sin square theta mg tan theta is equal to q square. So we have q is nothing but then multiply 4 pi epsilon naught. This one is going to be this direction, and R is 4 pi square. Then q is under root, and we have 16 pi epsilon naught L square sin square theta and tan theta. This will be your charge. This was charge. Okay, this is your answer. Now, another question. We have 3 particles, each of common mass, each of mass m and carrying a charge QH are suspended from a common point Y insulating massless a string each of length L if the particles are in equilibrium and are located at the corner of equilateral triangle of side A, calculate the charge on Q on charge Q on each particle. Assume L is much greater than A. This is your question. Okay. Just you have to think 3 dimensions, like we have like this equilateral triangle of side A, and this will charge Q, Q and Q. Well, and it is suspended like this. This is equilateral triangle, equilateral framework. It is suspended like this by common point. Suppose this is common point and it is suspended like this. So point of suspension, from symmetry, it will just above this one. This is point O. So it is just above this one. This is your height h, and it is suspended by the string and length L, like this, length L and length L. Okay. And the point of suspension, this point will pass through the centroid. Otherwise, how can it will be in equilibrium? There will be some torque, and it should be balanced its torque too. So this point of suspension will just be collinear. P will be collinear to the point O. So this is centroid. This is centroid, and any point in this plane will be perpendicular to this, and this will be L√3, and this is L. So we can draw picture of this triangle, this triangle. Okay, this is H and this is L, and this is O and this is A. You can consider this point A, B and C, A, and the tension will be like this, and mg force always downward, and F net, we have already done this same problem, that net force will be line joining this symmetrical point, and this is along a symmetrical point, so F net will be in this direction. So we have this, can consider this angle theta, and this is a by root 3. This will be angle theta. So this is tension, and this will be t cos theta, and in this direction t sin theta. Okay, then we have balance the force in opposite direction, F net. Now we need to find F net. We will find it. First, just balance the force t cos theta upward and downward, mg. So we have now, just divide the two equations. Tan theta is F net and mg. We just have to find q, then F net is nothing but mg tan theta. Now from geometry, how can you find the tan theta? P by B, A by root 3 YH. We have A by root 3 H. So well, I can go ahead. We have tan theta is nothing but A by root 3 by H, which is under root L square minus A square by 3. This is hypotenuse, so this is perpendicular, sorry, this is perpendicular, this is base. So we are left with A by root 3 L, because L is much greater than A, then L square minus A square 3, you can write L square. So we have tan theta. Okay. Now F net, if you are able to find F net, then you can find Q from this one. Well, F net, okay, this is your equilateral triangle Q, Q and Q, and this is your centroid. Just join this line and just join this line. So F net is this one along this. So this is the similar triangle. This is this one F net along this direction. This is your direction of the F net. Well, you can find the F, which is nothing but Q square 4 pi epsilon naught A square this is F curve and this is F net curve, and F net, this is theta and this is theta, this is 30 and 30, this is 2 cos 30 degree. To F cos theta. Now you can put here F net, you can find easily the Q. So we have 2 Q square 4 pi epsilon naught A square cos 30 degree बराबर mg tan 30 degree A by root 3L. So you have Q is nothing but mg 4 pi epsilon naught A cube cos 30 degree root 3 by 2 is going to be cancelled. Now we have 3L to the power half. Okay, this is Q square. So this is your Q. Okay, just we are discussing and expressing the same formula for coulomb for force between the two charge, but for different configurations or different distribution of the charge. We are studying only discrete charge, and it's kept in the space in different way, and just we are trying to find the force and evaluating the parameter whatever asked when the system is in equilibrium. Now suppose illustration, new question. Now we have 4 identical positive charge each of value Q are arranged at 4 corners of a square of side L. Unit positive charge having mass m is placed at P at a height h above the center. Of a square, what should be the value of Q in order to keep the unit charge in equilibrium? It's your question. Once again, you have to think in 3 dimensions. We have a square like this, A or B, C and D, charge Q now this is your center and unit positive charge. This is unit positive charge is kept and mass m, so downward it has mg force, and this is your height, suppose h, and this will apply the force like this. Okay, and it is length of a square is L, and this will be L by root 2, and this is connected by the string like this and like this. Okay, so all will apply the electrostatic force to this point so that it can balance its weight, because two charges kept in a space will always apply electrostatic force in the direction will be line joining the two charges, and you know mg will always act downward, and these two force will balanced, then it will be in equilibrium. Well, this is very simple. This triangle, try to just make a clear picture of one triangle. This one is L by root 2 and this is your H, and this one force, this is your theta, and this force will be like this F. Then we have theta, F cos theta and F sin theta. Okay, so F electric force is due to 4 point charges. It will be 4 K. K is the constant. K stands for 1 by 4 pi epsilon naught. This is Q. So Q, in this is unit charge, into 1 by this distance is just for use the triangle h square plus L square by 2 under root r square, so L square plus L square by 2 and cos theta. Okay, all this force will be equal to mg, the weight, to maintain its equilibrium. Upward force, this is upward force, and this will be downward weight. This force must balance weight. If sin theta is acting in horizontal direction, so it all will cancel each other. Now we have cos theta. Use the geometry, triangle. This is triangle, so theta, use the theta and length. You can find a cos theta b. This is p and this is b. B by h under root h square plus L square by 2. So we have this balance this equation. 4 k q h by h square plus L square by 2 is to 3 is to 2 is nothing but mg. This, when you multiply this one, power 1 and half, add, becomes 3 by 2. Now q is 4 k mg by h into h square plus L square by 2, 3 is to 2. Sorry, this will be, sorry, mg h square plus L square by 2, 3 to 2, 4 k q h. So q is mg h square plus L square by 2, 3 is to 2 by 4 k h. This is your force, sorry, charge. Okay, one more question. We have, this is your ring. Suppose this is ring, thin ring of radius A has positive charge Q uniformly distributed, distributed over it. Okay, q charge is uniformly distributed over it. Now this is your ring, like this. This is a particle and its radius is a, and a particle is kept at a distance x at the point A. Here these have negative charge q and mass m, and x is very smaller to radius. Just for making clear picture, I am making it larger, but in real case this distance is very small as compared to the radius. Okay, as this distance is from the center, this x is distance from the center. Now so that motion of negatively charged particle is approximately simple harmonic. You have to show this and also find the time period. This is your question. Time period of oscillation. Okay, this is your system. One is ring, another is point charge. This is positive charge and this is negative charge. Just you fix this configuration, you find this charge is oscillating like this. First prove whether it will oscillate or not, whether it will oscillate with SHM. Then you have to find the time period. Well, we have this ring radius a and this distance is x. This is minus q charge having mass m. This is a continuous body, so we can't write these forces as q1 into q2, but just keep it simple. Take a elementary charge dq on this ring. This is a small dl length having charge dq. Then this dq and q point charge will apply the traction force, will attract this force. Now this force is df. Now you can see Coulomb's law you can apply for a small charge dq and charge minus q, and this is the angle theta. Okay, so component of this force in this direction is df cos theta, and df from Coulomb's law 1 by 4 pi epsilon naught dq into q by r square. This is r square and this is unit vector, and vector is this direction. Okay, and this force is in this direction, df cos theta. Well, this this much force is df cos theta. This will give oscillating force F on integration. Perform the integration, you will find the total force F. So we are deal with this quantity df. Integration df is this much, 1 by 4 pi epsilon naught dq q by r square, nothing but x square plus a square. Okay, r is under root a square plus a square. Now what is the cos theta? This is p perpendicular, this is the base, and this is h. We have cos theta is equal to xy x square plus a square to the power half. So we have force is equal to, this direction you can say negative direction, and this direction you can say positive direction. So force is negative considering the direction. We can write minus 1 by 4 pi epsilon naught qx by x square plus a square to the power 3:2 integration of dq. So we are left with the force minus 1 by 4 pi epsilon naught qx by x square plus a square 3:2, and this will give q. We know dq is q, this is total charge. Now from assumptions we have x square plus a square is equal to a square, because a is much greater than x. So we have final expression 1 by 4 pi epsilon naught qx and qy a to the power cube. Okay, so you compare the force is equal to minus kx. Nature of the force when linear varying with x and negative with a constant, then this force will be this force will produce oscillating motion of SHM character. Okay, so nature of the motion will be SHM. Now we have left with k. Compare this equation with this one. K is equal to 1 by 4 pi epsilon naught q by a q, and we know k is equal to m omega square. Omega, you can find here omega. Now time period. Omega is nothing but under root k by m, and time period is 2k pi by omega. So we have time period is equal to 2 pi under root 4 pi epsilon naught m a cube by q. This will be your time period. Okay, so this is a question, basic question, because but I will add a lot of questions on Coulomb's law. So this is very basic questions we have discussed, and we will solve a lot of numerical problem in the next classes. Thank you.